Next problem we're going to look at is a precipitation reaction. Um, when phosphoric acid is added to 125 milliliters of barium chloride, 3.26 grams of barium phosphate precipitates. What is the molarity of barium chloride solution? The equation for the reaction is, and as we see below, we have 3 moles of barium chloride plus 2 moles of phosphoric acid goes to barium phosphate plus 6 moles of HCl. So the first thing we need to do is convert our moles of barium phosphate our grams of barium phosphate into moles of barium phosphate. So because we know the number of moles of that, so we ask ourselves the question, how many moles of barium phosphate is equal to 3.26 grams. So we have how many moles of Ba3PO4 2 is equal to 3.26 grams of Ba3PO4 2, and we know that for every 1 mole of Ba3PO4 2, we would have the molecular weight for this is 571 grams. So if we stop right here, our answer would be in moles of barium sulfate. But we really want our answer to be, because we're looking for molarity of barium chloride, we can use the stoichiometry in the balanced chemical equation, which tells us that for every 1 mole of Ba3PO4 2 that I produce, I will produce 3 moles of BaCl2. So stoichiometry tells me that for every 1 mole of barium phosphate, I have 3 moles of barium chloride. And now, when I do this, my grams of barium phosphate cancels out, my grams of barium phosphate will cancel out, and my answer will be in it will be in moles of barium chloride, which will be 1.7 times 10 to the negative 2 moles of barium chloride. Now, because I have my moles, I can now use my formula. Molarity is equal to moles per liter. My moles can go there. And I know the volume of barium chloride I have, which is 125 milliliters. Simply convert that into liters. So I would have 1.7 times 10 to the minus 2 moles divided by 0.125 liters of BaCl2, which would give me an answer that would say 0.13 molarity of BaCl2. Okay, that's a wrap.